Let's see another numerical on statically determinate structures. A member ABCD is subjected to point loads P1, P2, P3 and P4 as shown in figure 2. Calculate the force P2 necessary for equilibrium if P1 is 45 kN, P3 is 450 kN and P4 is 130 kN. Also determine the total elongation of that member if modulus of elasticity is 210 GPa. Okay. So first of all we find out the force P2. So this axially loaded member in statically equilibrium conditions. That's why we use a first equilibrium condition summation Fx is equal to 0 and find out the force P2. Okay, let's see by equilibrium conditions, by equilibrium equations. We know summation Fx is equal to 0. There are some sign conventions. If forces goes towards the right, we take positive, and forces goes towards left, we take negative. Okay, let's see that P1 force goes towards left and that P1 is 45 kN. That's why we write here minus 45. Okay, P2 goes towards right is plus P2. P3 is again minus 450 kN and P4 goes towards right, it is plus 130 is equal to 0. Okay, by solving all these we got P2 and that P2 is 365 kN. Okay, so simply by using equilibrium condition we got P2. So our step 1 is draw free body diagram and apply static equilibrium conditions and find out the internal forces in each member. So first step 1 is draw a BD and apply equilibrium conditions. So okay, so consider this is first member, this is second member and this is third member. Okay, so first of all we draw a BD of first member. Let's see, this is a first member. Okay, then we consider one section in first member. Here we consider a section in first member. See left side of forces. Left side of force is P1 goes towards left, it is negative and that P1 is 45 kN. Here I draw a force 45 kN. Then see right side of forces. Then see right side of forces. If forces are equal and opposite, then our calculation is true and we got the internal force in section 1. Okay, see right side of forces that P2 goes towards right, it is plus 365. It is plus 365. Okay, that P3 goes towards left, it is minus 450. And that P4 goes towards right, it is plus 130. By doing all these calculation, here we got a plus 45 kN. Plus means it goes towards the right, and here I got a force in first member, that is 45 kN, and that forces are pull type tensile. That's why that P1 is positive and it is 45 kN. Okay, again we draw a BD of second member. Here I draw a BD of second member. Okay, again consider a section in second member. See left side of forces. The left side of forces are, that is minus 45, then plus 365, and the calculation is 320 kilonewton. Plus 320. Plus 320 means it goes towards the right side. Here we got force 320 kilonewton. Okay. Again see right side of forces. Right side of forces goes, this P3 goes towards left and it is minus 450. And that P4 goes towards right, it is plus 130. So minus 450 plus 130, it is a minus 320. Minus 320 means this force goes towards the left side. And here the forces are equal and opposite. Our calculation is true and we got that P2. But these two forces are push type, compressive. That's why that P2 is minus 320 kilonewton. Okay, again we consider FBD of third member. Here I draw FBD of third member. Consider one section in third member. See left side of forces. The left side of forces are that P1 goes towards left side, it is minus 45. That P2 goes towards right side, it is plus 365. And that P3 goes towards left side, it is minus 450. By doing all these calculations, we got that P3 and it is a minus 130. A minus 130 means it goes towards the left side. Here I draw that force, it is 130 kilonewton. Okay, then see right side of forces. The right side there is only one force P4 and it goes towards the right, it is positive and it is 130 kilonewton. Both the forces are equal and opposite. Our calculation is true and we got force in third member and it is plus 130 kilonewton because it is tensile pull type. So our step 1 is completed. We find out the internal forces in each member by using FBD and static equilibrium conditions. Okay, next step 2. Step 2 is apply principle of superposition. What is principle of superposition? The total elongation or total contraction produced in that axially loaded member is algebraic sum of elongation or contraction produced in each member. Simple. So by applying principle of superposition, we find out the total elongation in that axially loaded member. That's why delta L is equal to delta L1 plus delta L2 plus delta L3. Okay, then we know what is delta L. Delta L is P1 L1 divided by A1 E1 plus P2 L2 divided by A2 E2 plus P3 L3 divided by A3 E3. Here the material is homogeneous. That's why the modulus of elasticity is same throughout its length. That's why we take E common. Here area is different, length is different, force is different. There is only modulus of elasticity is same. That's why we take modulus of elasticity common. That is delta L is equal to 1 upon E. Then our formula is P1 L1 divided by A1 plus P2 L2 divided by A2 plus P3 L3 divided by A3. Okay, then put all the values in that equation. We got a total elongation, that is delta L is equal to 1 upon what is modulus of elasticity? It is 210 GPa. Convert into MPa, it is 210 into 10 raised to 3. Again, what is P1? P1 is 45 kilonewton. Convert into Newton. This is 45 into 10 raised to 3. Into L1. What is L? L is 1200 mm. Divided by A1. And that A1 is 625 mm. Again P2. The P2 is minus because it is compressive. That's why we take minus sign here. That is minus 320 into 10 raised to 3, convert into Newton, into length of second member is 600, divided by area. Area is 2500 mm square. Okay, let's see P3. P3 is tensile pull type, that's why we take positive sign here. That is 130 into 10 raised to 3 into its length. Length is 900 divided by area, and that area of third member is 1250 mm square. Okay, then simply do that calculation. By doing all this calculation, we got the total elongation, and that total elongation produced in that axially loaded member is 0.491 mm. Okay, so by using principle of superposition and static equilibrium conditions, we find out the elongation produced in that member. Okay.